So hey guys, welcome back. This is Abhishek again, and in this video we are going to solve a Kaggle competition, and that is natural language processing with disaster tweets. So welcome to my YouTube channel in NLP playlist, and if you really like my work, please don't forget to subscribe my channel and hit the subscribe button and notification bell as well. So let's get started. So let's first understand what is this competition all about. So in this competition we have to classify a tweet whether the tweet is talking about a disaster means an earthquake or wildfire or heavy rain flood, all these things, or accident. So these all are disaster. I'm just not precisely talking about natural disaster. It could be any type of disaster, so you have to predict them by just seeing the tweets. Okay, so this competition comes in natural language processing NLP task. So this is NLP task. So for doing this competition I will be using Bert pre-trained model, because Bert are state of the art technology in natural language processing, and you should definitely go with this if you are practicing natural language processing. So in the previous video I have also talked about Bert, but that was for multi-class classification. I have explained Hugging Face, Transformer, Bert, and all these, so don't forget to watch my previous video. So let's first understand the insight of this data. So here we have three data, and the data is not really long. So we have sample submission, we have test CSV, we have train CSV. Okay, so let's first see our train CSV. So there are 5 columns, and you need only target text, and um, you don't even need keyword, because you can see that keyword is almost blank, so I'm not going to go with keyword. So here we need 3 columns. The first one is ID, the second one is text, and the third one is target. So target contains 0 and 1 because it's a binary classification, and if it's 1 it means it's talking about a disaster. So let's confirm it out. So okay, all resident asked to shelter in the place are being notified by officers. So it means the people are finding a shelter, so it could mean a disaster. And 30,000 people received wildfires evacuation orders in California, so this is also a disaster. So this means disaster, right? So we have to classify this. And in the test CSV we have 4 columns. Definitely we won't get our target column here. So in the test CSV, we have to predict this by finding whether it's a disaster or not. And here we have sample submission. The sample submission have a very big significance. I will explain you this thing later on, but just understand what sample submission tells us. The sample submission tells us the format of the data we are going to upload in the uh, in our prediction we are going to submit. So this is ID and the target. So here you can use this token if you just want to get this data over your Google Colab or somewhere else, so you can use that token, or you can just create your own notebook from here. So I will be using this method. Just click on the new notebook. Okay, so before solving, let me tell you that you can solve this competition by using your any of your machine learning algorithm. You can use scikit-learn. You can use I would suggest you to use ensemble learning as well. But is always uh, but is always outperform other model, because this is state of the art model, and the BERT is already trained on very big corpus. So but is kind of the top notch of scoring. So okay, we will create a new notebook from here. So I have created a notebook for you, and we will discuss each and every line of code from scratch. So I assume that you have created your new notebook from here, or you can just find my notebook and you can work along with me. So I will give you the notebook in the description box, or you can find my account on Kaggle, Kaggle, Kaggle.com, preacher code, and so this is my account. You can find just by putting a slash forward slash in preacher, and you can find my code. So I have shared you many code, and this is the notebook which I will say you to go with. So this is my own notebook which I have opened right here. So you can also copy my this notebook and work along with me, or you can create your own new notebook. So let's start. So before creating your notebook, after creating your notebook, just make sure that you have created with GPU, because the BERT is highly intensive GPU work. Okay. So you can see I have imported my dataset. Here we have train, test, and submission, sample submission, right? Okay. So just run this and import NumPy and Pandas. And here you can see that I have imported warnings, because I want to filter every warning. We don't want any kind of warning, and that's why I have filtered this. Okay, this particular line of code is really important if your Kaggle auto completion doesn't work. But as you know that Kaggle has updated their notebook, and now the Kaggle notebook is really good for auto completion and suggestion. So I think I don't need this one anymore. So here I have imported warnings and filtered all those warnings. So here the name is action, I guess. So I'm using ID, text, and target columns only by using use calls. So I have created data frame, test data frame, and the sample data frame. And this is sample data frame. We really load that also. We really need to load that one also. Okay. So here we have test data frame. In the test data frame, you will be able to see that we have no any kind of target column, and in the train data frame we have a target column, and the shape of the train data frame is 7613. So this is not a very big data, so we don't need any kind of generator or TensorFlow dataset thing. So we don't really need that, because our RAM is enough capable to hold this amount of data. Okay. So always we have to understand that we have up to, until now we have just created our data frame, and that's all. So now, since we are dealing with natural language processing, do we need text cleaning or not? Okay, so let me tell you that the BERT BERT comes with their own tokenizer, and that tokenizer comes with 40 to 60,000 words, I guess, their own vocabulary. So we don't need to remove all the stop words, or we have to use porter stemmer to stem all those words. No, we don't really need that. We don't need any kind of extensive data cleaning. But I would also suggest you to remove all those accented characters and all those special characters, and for now that will be our text cleaning, right? Because BERT is state of the art technology, state of the art model, so we really don't need to do very extensive text cleaning. Okay, so to do any kind of text cleaning, I have created my own library that is named as text hammer. So I will just show you the functionality of this library, so you can use their own way to do text cleaning, as I think uh, you might be using your regular expression or whatever. You can use your own way, but I will also show this my method. So you have to do pip install text hammer. Okay, so this is a very small library. It has been installed, and so you have to import this import text hammer as th. And now okay, let it be done. Okay, so here we have created a function, and from tqdm.tqdm notebook, because I want a small nice looking progress bar, and that's why I'm importing tqdm notebook. And tqdm notebook.pandas, it will enable you to use progress apply method. I will tell you what are the progress apply method. So here we are creating a function. In that function we will pass a data frame and the column name of the column containing our text data. So here I have column equal to column, df equal to column name, progress apply. So if I just say okay, just say apply, so it will not show me a progress bar. But if I say that progress apply, then it will show me a progress bar. So I'm using lambda function, and I'm just lowering every words, and then I'm removing emails, HTML tags, and special characters and accented characters, right? So I'm removing all those things, and let's run it. And now since we have created a function, now we need to call that. So and in the column name we have to pass our column name which contains our all the text data. So text is that column which containing all the text data, so I have passed that. And we want to clean our train data frame, so let's run this. It will not take much time. So in the trend, since trained cleaned df has been created. Okay, so what I have done here, let me just move this to at this place. uh, just okay, it's fine now. So after cleaning this data frame, I have created a copy. I have created a copy so that if anything we mess up with anything, we don't need to do this again. So we will load this, okay, from here. So whatever change I will do in this trend df, it will not change our original cleaned data frame. So that's why it's always a good practice to make a copy. And here if I have used a value count just to know if we have any kind of data imbalance or mm, or imbalanced data or something like that. So you can see that the data is quite balanced. So if the data is balanced, you don't need to change threshold as our conventional machine learning. In our conventional machine learning, whenever we deal with imbalanced data set, we generally change threshold, we apply smooth and oversampling and sampling, all these things. But in BERT there is no any case of imbalance, because BERT is like but is a model which read line by line, so we really don't need any kind of oversampling or undersampling in BERT. But definitely you can try them just to know does this make any change or not. Okay. So far this data is balanced, so we really don't need to think about that. So now we have to load our BERT model, right? So we need to load our BERT model from cloud. So what we will do one more important thing. We need to do pip uh, install transformers, right? Transformers. So you have to do this one, and you have to import transformers, right? You have to do these things, but I have imported all these things. But in the Kaggle update, transformer is already installed, so you really don't need to do that. So what I have done here, from transformer import auto tokenizer and tf BERT model. Here tf signify that we are using TensorFlow, right? So tokenizer equal to auto tokenizer from pre-trained. I'm using BERT large uncased, but here we have BERT base cased and BERT base uncased. So what cased and uncased means? So this is all about lowercase or uppercase. So this is only that means, okay. So here we are using a large model. So large model, okay, the BERT base model is come somewhere around 500 MB, and the BERT large model comes around 1.47 GB, right? So since I want my model to give the maximum accuracy which we can achieve. So that's why I'm using large model, so that because we don't need to compromise with our prediction. So that's why I'm loading large model. So it will take a little time to download all those things, and meanwhile I will just explain you where you can find these things related to BERT. um, BERT base uncased. So you can see that this is downloading our model that is already pre-trained. So you can head over to huggingface.co/BERT base uncased. So you can see we have various models right here, and BERT base uncased, digital BERT base cased, and we have many models right here. If I just search BERT large, so you can see that we have BERT large uncased and BERT large uncased whole word masking, and we have various models you can see here, and you can use any of them. So how would you use that? So just click on that and click on the use in transformer. So it will show you how to load that model, how to load that model in transformer. So now you can see that since we are loading from transformer, so you can load from there as well. So this is you can see that BERT model has loaded in our notebook. So what we need to do, you can see that here we have a tokenizer. What tokenizer does, tokenizer converts our text data into BERT input form, because the BERT doesn't take direct text data. It need to be pre-processed in a very special format, so that tokenizer will do that. Okay, so if I just give a tokenizer as string, you can see here it will return a dictionary where we can see input IDs, attention mask, and token type IDs, right? So to train our BERT model, we need input IDs, we need attention mask, and token type ID is not that much important, because you can see that almost every data value are same in the token type ID. So that's why token type ID doesn't have that much significance in our training. Okay. So now we are going to start the process of changing our text data into BERT input format. So first thing we have to find the number of words, the maximum length of word in a tweet. So that's why how we will do that, we will find max len x dot split. I'm splitting every word so that we don't count our space as well. That's why we want to count only words, and that's why x dot split. If we won't split this, then this will show us the number of characters in that. And for x in train, so just run this, and you will see that we have 31 as max length of tweets, right? 31 words is the maximum length of tweets in our data. So now this step which I have here is really very important. So this is the changing of our text data into BERT input format. Okay, so what we will do, we will call the tokenizer, and then there is an attribute parameter name that is text, and in the text we will give a list of our text data, and that is train.df.text.toList, and that must be in a in a list format. And then add special tokens equal to true, and maximum length. So maximum length here is 36, but for security I have just given 36, and but maximum length was 31. You can give 35 or 34. Okay, never mind, I'm giving 34. And truncation equal to true. if any text we have more words than 34, suppose I have got a tweet having 60 words, right? So it will truncate all those extra words and that's why this is true. And this is padding. Padding means if any word come with less words, like okay, I have a tweet having only 10 words, so the padding will pad them by 0 and it will make that up to 34 words, right? So it will change the size of that tweet and make it equal to 34. And here return tensor equal to tf. So because I have loaded TensorFlow format of our Bert model, so that's why here must be TF. Return token type IDs. Token type IDs. I really don't need token type IDs, and that's why I'm creating I'm passing mentioning here false, because token type IDs, as you can see, this only contains 0 or 1, so there is no variation in data, and that's why this is not that much significance. Even attention mask is not that much significance. Even attention mask is not that significance. You can see here. So for training our BERT model, we can train only by passing input IDs. But I also want to give attention mask just to show you how we can train with train this by attention mask. Okay. So return attention mask. I want attention mask also. That's why I have passed here true and verbo is equal to true. So let's run this. So now what we have got here, if I just type xtrain, you will see this is our dictionary, and that dictionary have key as input IDs and the second key has attention mask. And the shape you can see 7613 and 34, 7613 and 34. 34 is the maximum length we have given here. So since it's a dictionary, so we can pass values. We can pass keys. You can see the shape of xtrain, attention mask and input IDs. So far we have created our x data for our training. So now let's do for y train, because we also need to pass the y. So what we need to do there, here we have train df.target.values, so we will get our y train. So that's very simple. Since it's a binary problem, since it's binary classification, so the data we will have in y will have only 0 and 1, so we don't need to do any kind of two categorical things, right? So now it's a really important step. Now it's time to build our model architecture. So I have imported these things. And you can also import that. I will not explain you what things I have imported, so you will get to know what I have imported from here. So maximum length equal to 36, and I am giving it 34, but maximum length was 31, but I have just given a 34. Okay, I have imported TensorFlow, and then I have imported input and dense layer. So input ID we have to pass here. So input equal to shape equal to maximum length, and that would be 34, and d type equal to TensorFlow int 32, because it will be an integer, and I have passed an input IDs. And I am creating the second input layer as input mask, because I will pass two data in X, and that's why we need to create two input layer. And the same thing here. And one very important thing is, whenever you don't need to mention this x rows, you don't need to mention this number of rows whenever you create your input layer, because that doesn't make any sense. How many data are you going to pass to our model? That doesn't that's not a business of model. We can pass any number of data. That's why we don't give the number of rows in our input layer. We only pass the dimension. So here I'm loading the Bert models which I have loaded. So here input IDs, attention mask I'm just passing out. So you can also give this in a list. Let me show you how you can do that. You can create a list and like this, and you can pass the data right that. And here this embedding this Bert layer output two things. The first one is our hidden state, and the second one is our pooled output, right? The first one is our hidden state, and the second one is our pooled output. So right now we have selected the pooled output, right? So the pooled output and hidden state have some difference. Let me tell you the shape of pooled output and hidden state. So the shape the shape of hidden states is um, none and the number of layer in this Bert model. So if it's 1024, okay, this is the number of layers in this, and the shape of pooled output is none 024, and here is a change, and this is our maximum max length. Okay, so this is the shape thing. Okay. Okay, so whenever we do any kind of classification, you can use hidden state, but if you use hidden state, then we have to use a pooling, and that's why I use a global max pool 1D. But if you are using a pooled output, so that's why since this is our tensor without any max length, so that's why we don't need any kind of pooling, and that's why I'm just commenting out this pooling, and I'm here selecting the pooler output. Okay, and then I'm just defining a dropout of 0.1 and passing the pooled output here, and then ReLU, and then here again dropout, and then again ReLU with 32 units, and here the dense layers of 1 since it's our binary classification. And then I'm just defining this model tf.keras.models inputs equal to input IDs and input mask, so the same name which we have provided here, and then output equal to y. And the main important thing is this input layer is our first layer, this is second layer, and the Bert model was the third layer, right? So the Bert model comes at second index, so we have to give model dot layers and index is equal to second dot trainable equal to true, because we want our model to be trained, because the pre-trained model of Bert comes for mask prediction, and that's why we need to train that again. And whenever we do our custom task, we need to train that. Okay, so just run this. It will take a little time, not that much, and here we go. So you can see the model dot summary. You can see the shape here, it must be 1, and if it suppose it's some multi-class classifications, then output must be that numbers here. Now it's time to compile our model. So optimizer I'm using ADAM, and learning rate I'm giving 5 e की power minus 0.6. So the learning rate is here very small, and this learning rate we have found out from this website right here. So you can see here the learning rate on this website. So the Bert model, we whenever we train Bert model, we have to give a learning rate, and that learning rate is really very small, and you can find that learning rate in this website. How to find those learning rates? Just click on the model, and suppose we are going to do text classification. So just click on that, and we have some model right here for text classifications, and for text classification we have some model right here. Suppose I selected this model, just for surety. And you can see the learning rate is 1 e to power minus 5. So you can see that how to find that learning rate, or you can find k tune to find learning rate. But for now, just keep in mind the learning rate for BERT training would be very small, and that can be found on Google or that website on Hugging Face. And epsilon, this one dk, I want the learning rate to be reduced if our accuracy doesn't improve well. And this is clip. And here loss, I have set a binary cross entropy from logical to true. That is pretty probably the same thing as probability, and this will normalize that. And here matrix equal to binary accuracy, and here I am passing accuracy, and then I am compiling it. Atom is not defined, so I think I have just missed this one. Okay, now just compile the model. And the plot model show shapes equal to true. If we will do this, this will show us the shape and all the model diagram. Okay, so this particular code will confirm if you are connected with GPU or not. So you can see name equal to physical device GPU, and device type equal to GPU. If you want to check the CPU, you can do that also. Here the CPU equal to 0 means just one CPU, and this is same as index. And now it's time to train our model. So we will pass that dictionary just here. We will pass that dictionary here. Okay, just make it more bigger. So train history equal to model dot fit. So x equal to create a dictionary with input IDs, x train input IDs, and attention mask, and y train equal to same as y train. And I'm also passing a validation split of 0.2 so that we can find our validation accuracy. And here I will pass just one epoch, because I think that epoch is enough to visualize how much accuracy we are going to get. And batch size equal to 24. Now let's run it. Python is not defined, so just let me check again. So I think I have not run this command. Okay. Now run this. So it's gonna take some time, so I need to pause the whole video recording. Just wait until it start, and then I will pause. After training, we will perform the testing phase. Since it's a BERT large model, that's why it takes time. And if you really want to save your time and no compromises with accuracy, you can use BERT base model, and that has 12 layers, I guess. So it has started, and you can see this is our accuracy increasing. 58, and the training has started. We have to wait for it until it finishes, and I will just pause the video. So you can see that now accuracy is started increasing. 59.59 means 59% accuracy. Now you can see this is uh, keep increasing. I think I need to run this for 2 or 3 epochs to get almost 81% of accuracy or 85% of accuracy. We need 2 epochs, I guess. So as you can see, we have just ran for just one epoch, and you can see that our validation accuracy comes out 81%. So that's fine for now. You can run various epochs in your notebook. So it's testing phase, right? So you can see our testing data, and that looks something like this, and it really need to be cleaned. So for cleaning, you can perform that function which we have created for cleaning, text pre-processing. Here we have to pass the data frame and the column name. So you can perform this step, but for now, for uploading purpose, I'm I'm not going to perform text cleaning. because I have also shown you how to perform text cleaning, but right now I'm not going to do that just to save time. Okay, let's run this. It won't take much time. Okay, let's run this. Here we go. It didn't take much time. Test df. Now look at this. Now it looks much cleaned. uh, Earthquake. So it looks much cleaned. Now we are ready to make this data in Bert input format. So to change this data into Bert input format, we need to use the tokenizer. Here we have to pass the text, and that must be in a list. So I have just given two list and add special tokens equal to true maximum length that has previously defined as 34. So I have mentioned that, and here written tensor padding truncation. We don't need token type IDs. That's not significance. And here attention mask equal to true, because we also need attention mask. And let's run this. So for model prediction, we have to pass the dictionary again containing input IDs and attention mask here. So we will get the predicted. So the variable name is predicted. So let me show you what is our predicted. Wait until it finishes because the test data is big enough. So you can see we have got some prediction, and if I just check the shape, so this is 3263 rows and one column. That's fine. And now we have to change them into 0 and 1. So I'm using np.where. Wherever the prediction is greater than 0.5, it will change that with 1, otherwise it will be 0. Now let's check the shape of y predicted. Y predicted dot shape. So the same. Okay, we don't need this thing. We don't need this thing. And now we have imported our sample df. As you can see, very before that we have imported that sample df, and what we need to do, we need to just change that sample df ids with test df.ids and sample df predicted with y predicted. Now I'll just run this, and let's see what is our sample df. Sample df. So now you can see that we have IDs and we have our prediction. We have IDs and we have our prediction. So what you have to do, you have to just give the sample df.toCSV, and here you have to give the CSV name and index equal to false, because we don't need this index to be included in our saved CSV. Now run this, and this CSV will come in your output, so you have to download from there. So you have to download this from here and download it. So download it on desktop. Okay, that's fine. And now it's time to upload that. Just click on the data and click on the submit prediction. So click on that submit prediction. Okay, you have no more submission today. So I guess it will come around 82%. And you can see my submission. Just let me show you overview my submission right here. So you can see with one epoch I found out 81 this is score, and with almost 5 epoch I got this one, and this one 83 63. I got this accuracy with text cleaning and performing. Oh, this is actually with text cleaning, not without text cleaning. So you can see my all these submissions. So thanks for watching this video. We have done whatever we needed to do. That we needed to predict our whether it's a disaster or not. So we have done that. So thanks for watching this video. If you have any question, please don't forget to leave that in comment box. I will answer them. Thanks for watching this video. Have a nice day.